In this video, I'm going to go through solving the SK8MAN problem using OpenSolver. So you can see I've got my problem formulation and I put it split screen so I'd be able to read the equations. And then I've got my two product version of the spreadsheet. And so I've got SK8MAN up in A1 so I remember which problem it is. And when you start out, the decision variables will be blank. So the decision variables, number one is we want to know how many sporty skateboards to make, and number two, we want to know how many fancy skateboards to make. Decision variables should be numbers, but they can be any number you want. It's just numbers so you can double check the computer's doing the math right. I like to use numbers like 2 or 5 or 10 that I can figure out pretty easy what the math would be in my head. So the objective function, that's how much money we make if we make one of these things. So if I make a sporty, I would make $15. So 15. If I made two sporties, I'd make $30, right? For the fancies make more money. They make $35 each. And then in column D, that's going to be my formulas for everything. So that's where I multiply and add together. So the number of sporty times the amount of money you make for one sporty plus the number of fancy times the amount of money you make for the fancies. If I made two sporties and 5 fancies, that'd be $205. Any other numbers and it'll redo that math for me. All right, so then my constraints, that starts out blank. I started typing them in. So my first one is shaping time. My second constraint is the number of trucks that we make or that we use. The next constraint is North American maple. And then the last constraint is the amount of Chinese maple we use. All right. In this region, we're going to put the number of each of those things that we make for one sporty or one fancy. So it takes 5 minutes to make a sporty. It takes 15 minutes to make a fancy. It's a harder wood. For trucks, every skateboard uses 2 trucks, one in the front to hold the front wheels, one in the back to hold the back wheels. So 2 trucks for a sporty, 2 trucks for a fancy. North American maple is used for the fancy board. It's not used for the sporty, so the sporty would use 0. The fancy would use 7 veneers, because these are, remember, sliced into small thin sheets of wood and glued together and pressed. So 7 veneers for the North American maple for the fancy. The Chinese maple uses 7 veneers for the sporty, 0 for the fancy. The fancy uses North American. So then we're going to put in our formulas. If we made 2 sporty and 5 fancy, how long would that take? We're going to do the same math as before, equals the number of sporty times the number of minutes used for one sporty plus the number of fancy times the amount of time used. That would take 85 minutes to make 2 sporty and 5 fancy. So then what I'm going to do is I could put the same kind of formula in for all of these, or if we remember the shortcut of putting a $sign in front of the things you don't want to change when you fill down. So I don't want row 4 to change. Each time I want to multiply by the number of each kind of board I make. So a $sign in front of the 4 for B, a $sign in front of the 4 for C. We're not going to put $signs in front of the 9s because if I fill this down, if you click on the bottom right corner and drag down, it'll fill down and it will do that math for us. So now we need to put our limits on the right side. So the maximum amount of shaping time is 8 hours per day, 5 days per week, 60 minutes in an hour, since these are in minutes. So we'll put that over here. We could do the math, or we can let the computer do that math. So I'm just going to let it do the math. 8 hours times 5 days a week times 60 minutes in an hour, and it says that's 2,400. For the trucks, I know that my supplier can supply up to 700 trucks per week. North American maple, my supplier can give me up to 840 veneers per week. And then Chinese maple, my supplier can give me up to 1,470. So the problem's all set up. The next step is to use Solver to solve it. So I'm going to go up to my add-ons, go to Open Solver, and open that sidebar. It's covering up part of my screen, so I'm going to cover up my problem here for a minute while I solve it. So the objective cell, we want to maximize profit, so I'll click on D6 and update my objective cell. I want to maximize money, so I'm going to click maximize. These are the two cells that I want the computer to change to figure out the right answer that it's going to put numbers into. So select B4 and C4 and click add for variable cells. And then my constraints, notice it says unconstrained variables non-negative. So that's my non-negative production constraint down here. I don't have to put one in for that because it's just a checkbox. And then for my constraints, I want all of the left side, update on the top, to be less than or equal to all of these on the bottom. And save that constraint. And then I can solve the model, and the computer will try a whole bunch of different numbers, and it will come up with the best production rates for these. It says I should make 210 sporty, I should make 90 fancy, and my profit will be $6,300 per week.